Hi everyone. Today I'm going to present you about digital logic circuits. I'm just going to give you about the introduction about digital logic circuits. First, what is the importance of digital circuits? Why we want to know about the digital circuits? Because the digital systems they play a prominent role in our day-to-day life. The present technological period we can say it is called as a digital age. Uh, Before going for digital circuits, we should know what is an analog signal and what is a digital signal. An analog signal is a continuously varying signal. So that's what given in this graph. So the signal which is continuously varying with respect to time. For example, the speech what I am delivering now, it is a analog signal because the sound is produced by the vibrations of vocal cord. The speech is continuously varying. It is not a fixed one. It is continuously varying with respect to time. So this comes under the category of an analog signal. But whereas a digital signal, it has discrete levels. It can be either 0 or 1. So this slide will give us a clear idea about analog and digital. So a continuously varying signal, time varying signal, it may be a voltage or a current or any form it may be. It's called as an analog signal. So for designing an analog circuit, what are the basic elements we require are resistors, capacitors, inductors, and transistors. So these are the basic elements which are required. But in case of digital, the signal is considered as discrete signals which are sampled with respect to time. So as I mentioned previously, there are two possible values. It can be either logic 0 or logic 1, which can be logic 0 can be represented by either 0 voltage, low or false signal. And similarly, logic 1 is denoted by either 5 volt, high or true, whatever may be. So in short, a digital system is one which have only two discrete values, either it may be logic 0 or logic 1. So similarly, for designing a digital circuit, the basic elements which are required are the logic gates. Here I am given the only the basic logic gates which are required for designing a digital circuit. The basic circuits logic gates are and, or, and not. So this slide I given some pictures of the components which are used for storing an audio signal. That is, we can store our favorite songs in any of the components present here. Here you might have seen these audio cassettes where you can store your audios, that is your songs or anything, audio information can be stored. Similarly, you can also store the same audio information in the pen drive or a CD drive or a DVD, whatever forms it can be stored. Okay? Now, but the way in which that particular song is stored differs from this method, that is this audio cassette, compared with that the data stored in the pen drive or CD or DVD. Okay, what is the difference is here in case of audio cassettes, the data or the information is stored in the form of an analog information that is continuously varying information, which is stored in the magnetic tapes. Okay, so this is the usage of storing your audio signals in your audio cassettes. But in case of your pen drive, CD or DVD, also you can store your data or your songs, but it will be stored in the form of digital information. So these are the different ways in which you can store your information, but this is the way of storing your analog data, and this is the way of storing your digital information. Okay. These are the different digital devices we use in our prominently in our day-to-day life. We may be using our desktop PCs or laptops, digital cameras, MP3 players, iPad, notepads, mobile phones. So all are these are the digital devices which we use mainly in our day-to-day life. So in short, I can say that our day starts and ends with a digital device. So one or other way, we rely upon a digital component or digital device for our daily usage. Okay. So I have listed out some of the applications of digital systems. They are used in communications, traffic control, spacecraft guidance, medical treatment, weather monitoring, commercial applications, industrials, digital telephones, digital televisions, so DVDs, storage, digital cameras, your digital computers. So these are some few of the applications of digital systems. Okay, what are the advantages of digital system? Why we prefer for digital systems? The reasons are ease of programmability. You can program or you can design a digital systems according to your choice. Reduction cost of the hardware. That is, the design cost will be reduced. So the hardware, whatever you are going to implement for this design, will be reduced. So faster accessing of your data, so high speed access is possible, high reliability, you can rely upon the data at a higher rate, the data will be accurate, the chances of noise or corruption of the data will be less. And design is easy compared with the analog circuit design, and the results can be reproduced easily. Okay. Uh, okay, before going for a simple digital circuit design, I given a smart home application where using a simple mobile phone, the entire control of your home can be done by means of this mobile device, which is a digital device. Your LED light, which is in your home, can be controlled. Your windows can be either shut off or on, can be done by means of this mobile device. Your light can be made on or off. Your air condition can be controlled. Your television set-top box television can be controlled. Your thermostat, the temperature of the room can be controlled. Everything can be controlled by means of the smart home applications. All this are comes under the category of digital systems. Similarly, the present trending technology is Internet of Things. In short, it is IoT. It has applications in varied domains. Uh, Home, what we have seen in the previous slide, where your entertainment purpose, you can use it, security, utility and applications, health, and in case of social concern, it is for parking, emergency services, traffic, logistic services, highways, we can use. For the community aspect, we can use for the environmental surveillance, retail, factory, smart metering, energy metering. For the nationwide applications, the entire infrastructure, smart grid, remote monitoring, defense applications. So everywhere, this Internet of Things plays a role. So to have a thorough knowledge about the Internet of Things, we have to know about the digital logic circuits. What is a digital system? How a simple digital circuit can be designed. If we have an basic idea about digital circuit design, then we can explore the field of Internet of Things. So the very basic logic circuits in case of digital is combination logic circuits. The combination logic circuits for any digital system has consist of logic gates where the output at any instant are determined from the present combination of inputs. That is, whatever the inputs you apply, only on the present combination of the inputs, the output will be decided. Okay, based on the input and output design, you can values, you can design the logic circuit. Okay, so this is a combination circuit where you have n inputs and m outputs. Depend upon the n inputs presently you are giving, the m outputs are designed. So for each of the m outputs, you have to form a boolean function, and then output variable has to be defined. So this is a simple 5-step procedure for designing a combination logic circuit. So first, we have to find the objective of our design. So what is the specification of the design? That objective has to be denoted. For that specification design, what is the number of inputs you require and what is the number of outputs you require? So that has to be determined. And then assign the symbol for each input and output. How many variables you have, that has to be designed. And then afterwards, form a truth table. That is a table relating the inputs and outputs. That table has to be formed. After forming the input truth table, and then a Boolean function can be derived. That is how you relate your output with the inputs can be designed. It can be denoted in the form of a simple expression for digital logic circuits. That expression is called as a Boolean function. After you realize the Boolean function, that can be implemented using a logic circuit. Either it may be a basic logic circuit or additional universal gates, or any form it can be. Okay. This is a simple circuit design, which I'm going to explain now. So here you have been asked to design a combination circuit with 3 inputs and 1 output. The output is 1 when the binary value of the input is less than 3. The output is 0 otherwise. So here we are going to design a combination circuit with 3 inputs. So the number of variable input variable is 3. So we have decided as the input variable as x, y, z, and 1 output. Let us assume that the output is 1, which is denoted by the variable x. The output is 1 when the binary value of the input is less than 3. So here, since we have 3 input variables, we have 2 power 3 combinations. So 8 combinations you have denoted 0, 0, 0, 0, 0, 1. Likewise, it will start and end till 1, 1, 1. When the value of the input is less than 3, so this is 0, 1, 2, 3, 4, 5, 6, 7. So when it is lesser than 3, that is only for these combinations 0, 1, 2, the output of the function is 1. For the other cases, the output is 0. So that's what the information, that is the objective of the circuit. So that we have denoted from that statement, and that statement is represented in a truth table. So the truth table denotes a relationship between the input variables and output variables. And then from the truth table, we have to form an expression. So we, that is a Boolean function has to be derived. This can be derived by means of an either Boolean algebra simplification, or we can use the K-map method, that is Karnaugh method, which is used for simplifying the Boolean functions. So I have three variables x, y, z. In this three variable, for which combination the output is 1, that is denoted in this map. These combinations 0, 1, 2 combinations, the output is 1, represent in this. And then you have to group the values according to the specific rules available. These two are adjacent ones, these are combined, and these two are adjacent, which can be combined. Okay, then the expression for these two terms are f equal to, that is the output function f equal to x bar y bar plus x bar z bar. So this is the output function. So x bar y bar with the dot, that means it's an AND gate. So x bar y bar is denoted by obtained by an AND gate, and x bar z bar obtained by another AND gate. These two outputs are given for an OR gate. It's a plus symbol. So the final expression is derived. So this is a simple circuit for meeting our objective. So what is our objective? We have three inputs x, y, z. One, only when the value of the input is less than 3, the output value will be 1. Likewise, if the other, for the other cases, the output should be 0. So this is a simple digital circuit which we have designed according to the objective. Okay. So likewise, depend upon the application, depend upon the scenario, what we have to implement, these digital circuits can be designed. Okay, now I have given you a simple concept, very simple introduction about what is digital logic circuit. Our basic combination logic circuit has been designed using a simplified schema. So thanks for listening.